Welcome back. In this session, we'll solve chapter 4 student workbook problems level 2. Okay, write down the first problem. The op-amp of figure has a very poor open loop voltage gain which is 45, otherwise ideal. The gain of amplifier equals to this is problem number 6. For this session, problem number 1, but we already solved 5 problems before. Problem number 6. The circuit is an open loop gain A is equal to 45 without any feedback. Then what is your closed loop gain with feedback? That is what is the answer. Okay. Option A 5, option B 20, option C 4, option D 4.5. Okay. Listen. The virtual ground concept is valid only for negative feedback as well as if open loop gain is infinity or very high. Can you say the open loop gain is infinity or very high? No, your open loop gain is not infinity. Therefore, virtual ground concept is not valid to find your V0 by Vi. If virtual ground concept is valid, we would have done the nodal analysis and then calculate, we will get the relationship between V0 and Vi, then we got it. But it is not like that. Okay. Just for your understanding, if you take an amplifier, then what is your closed loop function? If you take an amplifier, this is what is your open loop amplifier A, and this is what your beta network beta. Then output is sampled and it is fed back, negative feedback. Okay, and this is what your error voltage E of t, and this is what your feedback signal Vf, and this is what your output signal V0, and this is what your input signal Vi. Let us say Vf is nothing but beta into V0. And E of t is equal to Vi minus Vf. Okay. Then what is your closed loop function, closed loop gain? That is nothing but V0 divided by Vi is equal to A divided by 1 plus A beta. If A beta is very much greater than 1, then you can neglect 1, A will be cancelled, then it will be 1 by beta. But A beta is not very much greater than 1 because your open loop gain is 45. Then beta will be less than 1. If you combine, then it may not be very much greater than 1, then we cannot neglect it. Therefore, what is your closed loop gain? A divided by 1 plus A beta. If you know beta of this circuit, then problem is over. Okay. Therefore, what is your beta? Therefore, what is your beta? This is what is your closed loop gain. Okay. Including negative feedback. Therefore, what is your beta? Beta is nothing but feedback quantity divided by sampled quantity, that is nothing but your V0. Okay. Now, if you know beta, then it is easier, we can substitute because A is already known to you, then we can calculate the closed loop gain. Okay. Now, can I write the circuit something like this equivalently to find beta? This is what is your op amp. Let us say this is what your plus and then minus, this is what is your Vi. If you observe clearly, this is nothing but your beta network, and this is what is fed, and this is your V0, and this is what your 8K, and this is 2K. Okay. Now I can say this is what is your beta network, this is what is our beta network, and this is nothing but your feedback quantity Vf. Therefore, what is Vf? Vf is equal to beta into V0, and this is nothing but your error voltage E of t. Because plus minus, that is nothing differential voltage. Therefore, what is your gain? A into Vi minus Vf, that is what is amplified, and then that is what you are getting V0. Therefore, what is your beta here? Beta is nothing but 2K divided by Therefore tell me what is beta. Therefore beta is equal to 2k divided by 2k plus 8k 10k. Therefore beta is 1 by 5, which is nothing but 0.2. This is what is your beta. Now from equation 1, let us say this is what your equation 1. What is your closed loop gain? Closed loop gain AF is equal to A divided by 1 plus A beta. You substitute, then you will get the answer. A is nothing but 45 divided by 1 plus 45 into 0.2. Then 45 into 0.2 is 9, 9 plus 1, 10. 10 means 4.5. Therefore, what is your closed loop gain? Your closed loop gain is 4.5. Answer is D. But if open loop gain is infinity, then it is nothing but 1 plus R2 by R1. 8k by 2k, 4. You will get 5. Instead of getting 5, now you are getting 4.5. Okay. Answer is D. You take it. Done. Problem number 7. The op-amp shown in figure is ideal. R is equal to rho to L by AC. The phase angle between V0 and Vi at omega is equal to 1 by root over L by C. Circuit is option A pi by 2, option B pi, option C 3 pi by 2, option D 2 pi. Okay. This is root LC. Okay. Okay, let's solve the problem. What are may be? Can I say this is a negative feedback amplifier? Yes. And op amp is ideal? Is virtual ground concept valid? Yes. Let us treat this as ZF and let us treat this as Z1. Right? Then what is your voltage gain? We know that your voltage gain AV is equal to minus ZF divided by Z1. Okay. Therefore, what is ZF? ZF is nothing but minus R plus SL divided by what is Z1? R plus 1 by SC. Therefore, AV is equal to minus R plus SL divided by, if you take SC, then what you get? 1 plus SCR, and this SC you can take to numerator. Then what you get? Minus, if you take, this is nothing but S square L into C plus SCR divided by 1 plus SCR. Now if you substitute SC is equal to J omega, then what is your voltage gain? You follow me, okay? Then J square, therefore you will get minus, then minus omega square L into C plus J into omega RC divided by 1 plus J into omega RC. Right? Now if you take this minus inside, what you get? This is nothing but omega square LC plus J minus J into omega RC divided by 1 plus J into omega RC. Then what is your phase angle? Your phase angle is equal to tan inverse omega RC divided by omega square L into C, that is minus, and then minus tan inverse omega RC. Okay, then CC will be cancelled. Then what is your phase shift? Then your phase shift is equal to CC will be cancelled minus tan inverse, then omega will be cancelled, then simply R divided by omega into L minus tan inverse omega into RC. Now you need to substitute everything, where R is equal to root L by C and omega is equal to 1 by root LC. If you substitute, therefore minus tan inverse, what is R? Root L by C. Therefore this is nothing but root L by C divided by omega 1 by root LC, 1 by root L into C into L minus tan inverse omega 1 by root LC into R root L by C into C. If you do that, this is nothing but minus tan inverse, this root LC will come here. If you take inside, then it is L square into C divided by C root divided by L divided by L. I think everything is cancelled. CC will be cancelled, root L square, done, minus tan inverse, CC will be cancelled, right? Root L also will be cancelled, right? Root C, CC will be cancelled, root L will be cancelled. This is 1 basically. This is also 1. Therefore, minus tan inverse 1 minus tan inverse 1. This is basically minus pi by 2, which is nothing but 3 pi by 2. Therefore, what is the answer? Answer is C. Whether it is minus 90 degrees or plus 3 pi by 2, both are same. Okay. I'll give you 1 minute time, then we will see problem number 8. Done? Problem number 8. An op-amp has an offset of 1 millivolt and is ideal in all other aspects. If this op-amp is used in the circuit shown in below, the output voltage will be. Select the nearest value. Okay, that's fine. Option A 1 millivolt, option B 1 volt, option C plus or minus 1 volt, option D 0 volt. Okay, first of all, what is offset? See, if you take ideal op-amp, without offset is referred to input by default unless it is specified that it is at output. Okay. Now, if you take your ideal op-amp where gain is very high, input impedance is very high, all. Let us say this is what your V1 and this is what your V2 and this is what your V0. What is V0? V0 is equal to A into V2 minus V1. Right? If V2 is equal to V1, what I mean is minus plus, if you short both of them, and if you ask me what is V0, we are expecting 0 volt. This is what is our idea. We are expecting 0 volt. Okay, when both are same, both are same and some value, what it may be. But if you take practical scenario, right? If you take practical scenario, even though you short Pi, due to internal input offset, your V0 will be plus or minus your saturation voltage. This is what your practical op-amp. Because your op-amp is having very huge gain, whatever mismatch you have internally between inverting terminal and the non-inverting terminal, that is acting as a differential voltage. That differential voltage into very high gain, it will be either plus Vset or minus Vset. That depends on your input offset polarity. Then how to take that offset? Means when you short both of them, I want output to be equal to 0. Then only this equation is true. Otherwise, you will have some V offset. That offset will create offset into the gain. Now, how to make it? This is what is case 1 and then case 2, right? What people do to make it, right? Therefore, case 2, this is A. Now, case 2 and B. What we can do, you can give minus plus and you can create some offset externally. Therefore, this is what it could be plus or minus, that we don't know, but this is what your offset. We need to create a voltage source. Therefore, V offset plus or minus, we don't know anything. Then your output voltage will be 0. We need to adjust this. Such that your output voltage will be 0. This is what your practical scenario only. Both are same. We are adjusting input such that whatever input offset you are giving here between inverting and non-inverting terminal, that will be cancelled with respect to whatever you have at the input internal to your op-amp. Therefore, if that is what is cancelled, then V0 will be equal to 0, because indirectly you are making Vd is equal to 0. Therefore, this is what is called your input offset, input referred offset or input offset. It could be plus or minus anything. Now, what he told? He told that input offset is 1 millivolt given offset. By default, that is input offset is equal to 1 millivolt. It could be plus or minus, positive or negative. Then, if you have 1 millivolt offset, what is your output? Okay. Now, if I take it equivalently, even they are giving what you call 0 here, right? But because of internal input offset, we have some output voltage, right? Then what is that output voltage? That is what is asking, which is closest to output value, right? Now, what I do, it is not open loop op amp. Here, this is open loop op amp. For open loop op amp, this is what it is. But if you have closed loop op amp, equivalently can I draw like this? Equivalently, if I represent, this is nothing but minus plus. Let us say this is what is your offset. This is what is your offset, which is how much? 1 millivolt. Then this is what is your circuit. The offset, whatever offset you have internal to your circuit, that is brought out. And this is what your V0. Now this is what is 1 kilo ohm. 1 kilo ohm. Then let's see what your V0. Therefore, it is nothing but non-inverting amplifier. This is non-inverting amplifier. Then what your V0? Your V0 will be equal to your offset into 1 plus R2 divided by R1. Therefore, 1 milli into what is 1 plus R2 divided by R1? 1K plus 1K divided by 1K, which is 2 millivolt. Therefore, tell me which is the option nearer to your 2 millivolt? Option A. This is what is nearer to 1 millivolt. It's not equal, nearer to 1 millivolt from the given options. Therefore, answer is A. You can take it. Problem number 9. The circuit of figure uses an ideal op amp, for small positive values of V in, the circuit works as. Basically asking for what is the circuit. This is minus plus. We had seen this already. Okay, what is this? This is log amplifier. Okay, but let's see. For Vi greater than 0 volt, then only your PN junction diode will be in forward bias. We had seen this already. Why? When you open this, okay, then it is a comparator because there is no feedback. Then this is 0. If Vi is positive, when this is positive, then this is what is plus. Then negative is more, output will be what? Negative. Then your diode will be on. Therefore, only for Vi is greater than 0, your diode is forward bias. It is forward biased. Okay. Therefore, now, then if it is a negative feedback, yes, then negative feedback, then virtual ground concept is valid, yes, then virtual ground concept is valid. Virtual ground concept is valid. And now let us say this is what is voltage across the PN junction diode. Let us say this is V and the current is I. Then what is the relationship between I and V? I is equal to I naught into e to the power of V by eta Vt minus 1. You can take it like this. Okay. Therefore, approximately minus 1, you can take it approximately I naught into e to the power of V by eta Vt. Okay. Therefore, now tell me, if you apply nodal analysis, this is what is 0 volt, then tell me 0 minus Vi divided by R plus current, which is what is flowing, which is nothing but what, I naught into e to the power of V by eta Vt, right, is equal to 0. I am neglecting the minus 1 approximately. Then what is this value? If you take I naught into e to the power of V by eta Vt is equal to Vi divided by R, then e to the power of V by eta Vt is equal to Va divided by R into I naught. If you apply natural logarithm, V is equal to eta Vt ln Va divided by R into I naught. This is what is our V. But what is V? We know that your V is equal to drop across PN junction 0 minus V naught. 0 minus V naught. Therefore, this is nothing but what, minus V naught. Therefore, V naught is equal to minus eta Vt ln Va divided by R into I naught. This is basically log amplifier. This is log amplifier. Okay. We had seen this already. Kind of revision for you. Done? Okay. Now problem number 10. The frequency compensation is used in op amp to increase. This is what your frequency compensation or pole compensation or pole splitting. Right? What is that? If you take your op amp block diagram, this is V1, this is V2, minus and then plus, this is your V0. Internally it is having the first stage, second stage, The last stage driver. This is what your differential amplifier, and now this is what your common emitter amplifier, single ended amplifier. Therefore we have here Darlington pair, here also Darlington pair. Therefore this is your V1, this is your V2, right? This is CC amplifier basically, or Darlington pair, as well as this also. Okay, then this is what is again CC amplifier or buffer amplifier, and this is what your V0. Okay, now this is what is your two pole system, right? Because the poles from Darlington pairs can be non-dominant pole. Then if you have the root locus, what are all poles you have from differential amplifier? The pole from common emitter amplifier, you can say P1, P2, they are here, and then whatever non-dominant pole they are at infinity, you can ignore. Therefore non-dominant poles. Why they are at infinity? Because everything is having output resistance and output capacitance. Then the output impedance of your Darlington pair is very low. Then whatever poles you are having, right, R and then C, because the R0 and then load whatever you are having, right, therefore that value is, because R0 is very, it is almost 0. When this is what is 0, this value is at almost infinity. But it is having some R0, let us say R01, and it is also having some R02. Then this is what is having capacitor, parasitic capacitance C1, and then parasitic capacitance C2. Then these are all the poles which are defined. It is two pole system. When you connect feedback, if the feedback is having another pole, then overall it is three pole system. Three pole system may be stable, may not be stable. Then what people do? People do compensation. Therefore this is what is the cap, Miller cap people add, which is compensation capacitor. If you add that compensation capacitor, right, even if you are having small value of Cc, but effectively if you apply Miller's theorem, that Cc is coming effectively by A2 times of Cc, that will be coming here, C1 plus Cc, then your P1 will be moved towards origin, that will become dominant pole, that will be around 5 Hz, therefore your P1 will be dominant, it will be close to 5 Hz because of compensation, and then P2 will be non-dominant, therefore your P2 will be non-dominant. This is what is called pole splitting. Then effectively, due to compensation, effectively it is one pole system. Your op amp is one pole system. Therefore, indirectly, when I say one pole system, then your stability will be improved. Even though your feedback is having another pole, one pole system, and then another pole, two pole system, the less than unity gain frequency of your op amp, then we can say stability. Therefore, what for frequency compensation? To increase stability. To increase stability by pole splitting, by pole splitting. Okay, that is the answer. Whatever pole you get because of this CC amplifier is also not dominant, because this R0 is also very less, you can say almost 0 when you compare with R01 and R02. The pole is always because of output impedance and then output capacitance. Now problem number 11. In the given circuit from figure, if the voltage inputs V minus and V plus are to be amplified by the same amplification factor, then the value of R should be. Okay, the circuit is this is V plus, this is V minus, 10K, 20K, 22K, and this is 15K, and this is what is R. Okay. Now, okay, then what is our voltage gate, which is nothing but, let us say, A minus. Okay, amplification factor A minus, then take V plus 0, then is nothing but minus R2 by R1, which is nothing but minus 22K divided by 10K, which is nothing but 2.2. This is what your amplification factor. Okay, if you want to get the same amplification factor, then with respect to V plus, this is what, then let us say this is what your VA. Then what is your VA? Actually, what is mod A plus magnitude only, which is nothing but 1 plus R2 by R1, 22K divided by 10K into VA, right, which is nothing but 1 plus 2.2, 3.2 into VA. That is what is your mod A plus. Okay. Now, to get same amplification factor, same amplification factor between V plus and V minus, right, your mod A plus should be equal to your mod A minus. What is mod A plus? 3.2 VA is equal to 2.2. Therefore, your VA should be equal to 22 by 32, which is 11 by 16. Therefore, this is what your VA. Now, what is your VA? Find VA. VA is nothing but, we know that VA R divided by 15K plus R into VA is equal to V plus, right? Therefore, now okay, now you substitute VA is equal to 11 by 16, then you will be getting V plus. Then what is your V plus value? Your V plus is nothing but, from here we can get it, right? From this, what is A plus? A plus is nothing but V naught divided by V plus. Then what is your V naught? V naught is equal to 3.2 A VA into V plus. We can get it. Try to substitute and then try to solve, you will get the answer. We did something wrong. Can anyone tell what is that wrong? What is that? See, when I say mod A plus, this is nothing but what? This is not A plus, this is what is your V naught, right? Your V naught with respect to V plus or VA. This is nothing but your V naught. Okay. Then what is this? This is nothing but your V naught. Your V naught is equal to 3.2 into VA. Okay. Then your what is your mod A plus? Mod A plus will be equal to, that is nothing but V naught by V plus. That is what we need, right? But this is what your V naught. V naught is equal to 3.2 into VA. See, this is not A plus, right? A plus is nothing but V naught by V plus. Okay. Therefore, this is what your V naught. V naught is equal to 3.2 into VA. That is what we have. Therefore, what is the VA? VA is nothing but R divided by R plus 15K into V plus. That you substitute there, then you will get it. Call this as equation 1. Then 1 implies V naught is equal to 3.2 into VA, 3.2 into R into V plus divided by R plus 15K. Therefore, what is your mod A plus? Therefore, your mod A plus is nothing but V naught divided by V plus, that is the amplification factor, which is nothing but 3.2 R divided by R plus 15K. This is what is your mod A plus and this is what your mod A minus. If you call this as, okay, this is, let me call this as equation 1 and this is what is equation 2. Therefore, this is 2, right? And this is what your mod A plus and this is what is equation 3. Therefore, to get same amplification factor between V plus and then V minus, that is nothing but mod A plus is equal to mod A minus. What is mod A plus? 3.2 into R divided by R plus 15K is equal to mod A minus, that is nothing but 2.2. Then if you do this, 3.2 into R is equal to 2.2 into R plus 15 into 2, which is 33K. Then 3.2 minus 2.2 R, therefore R is equal to 33K. When R is equal to 33K, you will get same amplification factor. Whatever amplification factor you are getting from here to here, the same amplification factor you will get it. Therefore, what is the answer? The answer is 33K. Okay, fill in the blank. Then problem number 12. An op amp is used as a zero crossing detector if maximum output available from output op amp is plus or minus 12 volt peak to peak and slew rate of op amp is 12 volt per microsecond. 12 volt per microsecond. Then the maximum frequency of the input signal that can be applied without causing a reduction in the peak to peak output voltage. Okay. What or maybe this is what your op amp. Okay. Let us say, and this is what your output voltage V0. It is having power supply plus or minus 12 volt. That is what it is. And your input. This is what your V input. Let me call your input as Vm sin omega t. This is what it is. Okay. Then slew rate is 12 volt per microsecond. Then without seeing any distortion, what should be the maximum frequency? Okay. Now what is slew rate? We know that the slew rate is defined as, I already explained, dV0 by dt, the change in output voltage, and that to max. The maximum rate of change of output voltage. That is what your slew rate. Okay. Now okay. Therefore now tell me what is this. Therefore what is your V0? Your V0 is equal to having some gain, then A into this thing, A into Vm sin omega t. Right? But the maximum what you can get, this is nothing but maximum you can get, right? Is nothing but what? 12 volts only. That is what is our 12 volt or minus 12 volt, what it may be. Therefore now when you differentiate it, what you get? This is what is your V0 max. What it may be? V0 max into sin omega t. When you differentiate, what you get? V0 max into difference of sin omega t cos omega t into omega. Omega is nothing but 2 pi f. Therefore and this should be maximum. When is this maximum? This is maximum only when VO maximum, that is what? The maximum voltage, right? Into cos omega t is nothing but 1 and 2 pi f max. This is what it is. Okay. Now what is this? Therefore f max is equal to slew rate divided by 2 pi V0 maximum. Therefore what is your f max? Your f max is equal to slew rate is nothing but 12 volt per microsecond by 10 to the power of minus 6 divided by 2 into pi into V0 maximum, that is 12, which is 12 will be cancelled, then 10 to the power of 6 divided by 2 pi. This is what, if you solve, what you get? The 12th one you will get 1.59 kilohertz. This is what your maximum. Therefore what is the answer? Your answer is 1.59 kilohertz. This is 159. Okay. You try to solve. You will get it. The time is over. Okay. We will continue in the next sessions for the remaining things. Okay. Thank you.